Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Last time, we were talking about composite functions, and we saw how we find the domain. And of course, once you have the domain, you can also find the range um, of these composite functions. But another reason we started with the composite functions is to find the inverse of functions. You already know a lot of inverse functions in math, right? Even when you were in elementary school, you must have thought that addition and subtraction are inverse of each other, multiplication and division were inverse of each other. Later on, when you advanced a little bit, you learned that the square root and the square are inverses. Later, you might have seen that the natural log and e to the x are inverses. Sine and arcsine and all the trig function, the hypertrig functions, a lot of functions are inverse of each other, meaning they can cancel the work of each other, right? That's why when you solve, say, a linear equation or two linear equations and you say, okay, let me subtract this from both sides, it's because they are added. Or if you divide, you have 2x equals 10, you want to find x, you notice that x is multiplied by 2, so you apply the inverse function and you divide by 2. So common sense, right? You have a square, x squared is 4, so you take the root of both sides, and don't forget plus or minus. But that's basically it. So when we are talking about inverse functions, we are going to start with an easy one. I will show you how to do it, and then we'll discuss more about these functions. So I'm just going to use algebraic functions. I'm not going to give you a table because it's really almost the same concept, but I will go only over inverse functions given as functions of x. So let's say we take something so easy. So for example, I don't know, we can say f of x equals 2x minus 1, for example. Now see, what is the inverse function? What do I mean by inverse functions? I want you to give me another function that if I take the composite of f and that other function, I get x. Notice, when you were solving 3x minus 2 equals 15 or something, what do? You keep subtracting and adding and dividing and multiplying until you get x by itself. So here, we'll do something, the same concept. So how do we find the inverse even? So for example, if you tell me x squared, I can find the inverse of that is the root x, or is it? We'll see that later. But if it's more than one term, how do I find that? A very easy way is that you are going to say, okay, I'm going to switch these two guys. So let's call the inverse function for the time being, we're going to call it g of x, okay? So f of x becomes x, and x becomes g of x. And now I want you to give me an equation for g of x. Wow, so easy, right? I want g of x by itself. So what do we do first? We add 1 to both sides. And then we divide by 2 both sides. And you can see that g of x equals x plus 1 over 2. It's that simple. Just switch. But this is the inverse function. Usually we call it f inverse of x. I just call it g of x to reduce the confusion and tell you, okay, there exists a function called, let's call it g of x, that cancels the work of f of x, so to speak. So now we call it f inverse. So now if I say, remember from last time how we do the composite function, f composite inverse f of x. So I'm going to start with that, meaning I'm going to say 2, and then I see an x. So instead of getting x, I get the inverse of it, which is x plus 1 over 2. and then I subtract 1, right? That's how we did it last time, remember? You see that the 2 and the 2 for this term cancel, and you get equals x plus 1 minus 1 equals x. So what if I do the opposite? I say f inverse composite or of f of x, what does it equal? So I come here, say I see x. So instead of x, I'm going to write 2x minus 1 plus 1 over 2. Notice that the negative 1 and the positive 1 cancel each other. And then you get 2x over 2. You divide, you get x. So you say, okay, that's simple. I can do it for any function you give me. However, you have to be very careful because not every function has an inverse. I will show you why. Remember when we were talking about functions? Oh my God, where is my pencils? I do have a lot of pencils. One. And I say, suppose you have a function, f of x, y, or f of x, not exactly, but f of x equals x squared. How do you find its inverse? You say, oh, root x. Not exactly. Why? Think about it. In fact, if you replace the x with the y, or with f of x, you will see there is a problem here. Why? I'm going to explain it later, but remember when we said, how do we check a graph of a function to see whether it's a real function, an actual function? What did you do? Remember? Vertical line test. If I draw a vertical line everywhere, it cannot intersect the graph in more than one point. If it does, it's no longer a function, it's a relation. So when I do the inverse, what is the inverse of vertical line? Horizontal line. So if my horizontal line intersects the function in more than one point, I cannot find an inverse for that function. However, if I only take half the function, either this half or that half by itself, I can find an inverse for that. So first of all, when I'm asked to find the inverse function, the inverse of a function, I have to plot it and apply the horizontal test. If it passes the horizontal test, like this is a straight line, right? 2x minus 1 looks something like that. Oh, of course, that's a function that passes the, since it's a function, it passed the vertical test. And since it's passed the horizontal test, we call it a one-to-one function. What does it mean, a one-to-one? We know that for any function to be a valid function, there must be a unique value. For what? For every x. Every time you take an x, there is a unique value of y. Take an x value of y, just one value. And by the same token, for every y, there is a unique value of x. Notice if I do x squared and this is a y, this is the same y. So it gives me two values for x. Cannot be inverted. It's not a one-to-one. It's not a one-to-one. So to make it one-to-one, I'm going to say f of x equals x squared, and x is greater than or equal to 0. It's only this part. And if I do that, you will find that everything is reversed. What does that mean? If x is greater than 0 is the domain of this function, then x greater than 0, then y greater than 0 would be, I'm sorry, it would be the range of the inverse function. And if that's the domain, also the range is from 0 to infinity. So the domain, if that's the range of my function, then it becomes the domain of my inverted function. And since both of them are x greater than or equal to 0, we will find that the domain and the range, or the range and the domain of the inverse function is from 0 to infinity. Notice, I think it's clear that the inverse is the square root, but if you don't know it, we can say, we call that x, and we call that inverse of x squared. So to get the inverse of x by itself, I have to take the square root of x. Notice I don't say plus or minus as I should have if that was an algebraic equation, just because I limited the domain and the range to be from 0 to infinity. Okay? If I want this bracket, I would say negative root of x. If you plot that, you will get something that looks like that. That's f inverse of x equals root x. And they intersect, of course, at the point 1 and 1 and 0 and 0. Because the square root of 1 is 1, or the square of 1 is 1. And that brings us to another thing. The line y equals x is always going to be an axis of symmetry for a function and its inverse. This is going up to the right, and this would be going up to the left, or to the right and up. And this is up and then to the right, right? So it's the reciprocal, so to speak. Okay, let's take another example. Let's say I have a function f of x, and let's make f of x like a ratio of two linear functions. So for example, x plus 5 over 3x minus 2, whatever. Like we said before, the f of x becomes x, and the x becomes either we call it g of x or inverse. I hate to write it inverse of x. Sometimes we call that y and x, and then x and y and solve for y. So maybe we can do that. It's just f inverse of x is a lot of typing or writing, okay? So g of x is easier, or y. So here I'm going to say y plus 5, and then at the end, instead of y, I would replace it by inverse of x. Y plus 5 over 3y minus 2. So I'm going to cross multiply and get 3xy minus 2x equals y plus 5, because it's multiplied, they are multiplied by 1. And then I'm going to move all the things that have y, all the things that have x on the left and everything without x on the right. In fact, it's already there, right? Because I'm solving for this x. So I'm going to say x times 3y minus 2 equals y. No, what did I do? Oh my God. 3xy minus 2x. equals y plus 5. Yeah, I'm solving for y. I'm sorry. So we have to have everything containing y on the left and everything containing x on the right. So I'm solving for this y, which was x. Okay, we confused ourselves. Or I confused myself. So I'm going to subtract y from both sides. And then I'm going to add 2x to both sides. Or 2x plus 5. I'm going to factor out the y. And that gives me 3x minus 1 equals 2x plus 5. And then I'm going to divide both sides by 3x minus 1. And you get y equals that. This is the inverse of x. Okay, now let's check to see f composition inverse of f of x. What is that? I have an x on the numerator, so I'm going to write 2x plus 5 over 3x minus 1 plus 5 over 3 times 2x plus 5 over 3x minus 1 minus 2. I'm going to take the same denominator. Notice that when you take the same denominator and divide, they will cancel each other. So I can write without, or if it's confusing you, let's say over 3x minus 1, but later you don't really need to write these two denominators because they are the same and they will cancel each other. But to reduce confusion, I'm going to write everything and then we simplify at the end. So I have 2x plus 5 in the numerator, and then I'm going to add to that 15x minus 5. Notice the 5 minus 5 cancel each other, and that becomes 17x over 3x minus 1. Let's look at the denominator. I have 3x minus 1. So this becomes 3 times 2x is 6x plus 15. And then you have negative 2 times 3x is negative 6x. And negative 2 times negative 1 is positive 2. So the 6x and this negative 6x cancel each other. And I get 15 plus 2 is 17 over 3x minus 1. Okay, we learned that if I divide two fractions, I take the first one and multiply it by the reciprocal of the other, 3x minus 1 over 17. These cancel, the 17s cancel, and you get x. Likewise, if I start by doing this, right? So I want to find f inverse composition f of x. I will get 2 times x, which is 2 times the original function, f x plus 5 over 3x minus 2 plus 5. Notice the 5 is not divided. This replaces the x. So if I have 2x, it's 2 times this whole thing, plus 5 divided by 3x, so 3 times the same thing, minus 1. So like we did what we did with the previous function, we are going to do the same thing. Denominator is 3x minus 2. Denominator is 3x minus. That's why I said you don't need to write it. They will cancel each other when you invert the second fraction. Anyway, you have 2x plus 10 plus 5 over 3x. Oh, I'm sorry, not plus 5. What did I say? 2x plus 10, and then notice the 5 has to be multiplied by that to get a common denominator. So plus 15x minus 10. For the denominator, you get 3x plus 15, and then a minus 1, meaning minus 3x plus 2. Simplifying or combining like terms, I get 2x plus 15x is 17x as before, and 10 minus 10 are canceled. Over 3x minus 2, I get 3x minus 3x cancel, and 15 plus 2 is 17, and you can see that we are getting the same exact stuff as here. So that becomes 17x over 3x minus 2, and then you multiply by the reciprocal, which is 3x minus 2 over 17. Of course, these cancel as before, exactly as before, and we get x. So we know that we did it correctly. Okay. Of course, when you do, I didn't go over the inverse trig functions, but you know that, for example, just quickly, and then maybe we'll have a session on that. Or better even, let's use the calculator and check what, of course, this is, well, let's plot that. So I'm going to go and plot 3 things. I'm going to plot f of x, and then I'm going to plot the inverse of f of x. And then I'm going to print or plot f of x equals x to make sure that this is the line that is a line of symmetry. Let's check the window. Well, I can go, say, from negative 10 to 10. Then maybe negative 20 or negative 25. And this is 10, 20. Okay, to 20. This is the axis of symmetry. That's one line. No, that's the middle one is the axis of symmetry. And this is one line and another line. Okay? You notice something interesting. Notice that if 2 lines were perpendicular, if they are straight lines, then the product of the slopes would be -1. If they are parallel, they have the same slope. But here, the reciprocal, the slope, if that's 2, that becomes 1/2, not -1/2. Meaning if I multiply them, I get 1, not -1. That's when the y equals x is a symmetric or axis of symmetry. Okay, so let's go back and do the second and the last one we did. So here I'm going to draw x plus 5 divided by 3x minus 2. And here I'm going to plot 2x plus 5 over 3x minus 1. And the third one, I'm going to leave it as it is. I don't know if the window is good enough or we can check. Okay, this is one graph. Maybe we needed to make it clearer. So I can zoom or I can change the window. There is no reason to have. Oh, let's make it a big one and see. I don't know. It's just because it looks like that, then if you switch it, if you switch the x and y, it seems like it turns out to be almost the same. So here really we didn't see that. It seemed like it's the same graph and the line y equals x is an axis of symmetry. If we try to do, no. I think we can, we can stop here. One thing we can do, let me think. What if I pick a value for x. Okay, I want to show you something. What value would be? Let's say if I take a value of 3, anything, then f of 3 would be 8 on the top and 7 at the bottom. Now, let's take here inverse of 8/7 and see if we will get 3. If I take the inverse function of that, the first term is 16 over 7 plus 5, and the bottom would be 24 over 7 minus 1. 5 times 7 is 35. When you add it, you get 51 over 7 divided by, this is 24 minus 7, meaning 17 over 7, equals 51 over 7 times 7 over 17. These cancel, and 51 over 17 is 3. If you don't trust me, of course, you can use the calculator and say 51 over 17, but I will be so sad if you don't trust me. And you can see that when we took f of 3, we got a value. When we take the inverse function, you enter the result, and you should get the input, right? And I hope that wasn't too confusing. If I didn't mean to confuse you. If I did, I apologize. But again, the main thing that you have to understand is that for a function to have an inverse, it has to be a one-to-one, meaning it passes both the horizontal and vertical tests. Okay, and if it does, the domain of the first becomes the range of the second, and the range of the first becomes the domain of the second, meaning y equals x, we call it like, okay, so y equals x is the axis of symmetry, or the origin is a point of symmetry. Okay. And I think that's about it. If we had taken this branch of the x square, we would have gotten, again, in order for the y equals x to be an axis of symmetry, it would look something like that. Which is, well, we didn't really draw it properly, but anyway, negative. So again, if we say, should we say that? So if we take, yeah, but this is f equals x squared for x less than 0. So that becomes the range is less than 0. And it's the same thing. What did I want to say? I think we stop here. I mean, we can plot it, but you will get the negative root of x if you take the left branch. Should we take another example? I think we did a linear, a square. If you do a cube, you get the cube root, and here that's a fraction. And I think that's pretty much what you should expect in the pre-calc course. Okay, if you have any questions, again, let me know by dropping me a comment in the comment section, and I will try to get back to you as soon as I can. Otherwise, I wish you all the best and hope to see you soon. Bye.